We are going to demonstrate our situation management system by displaying data collected from various Patho CERT technologies. We map the pilot cities with currently operating scenarios on the globe. Firstly, we want to show you how we applied for Limassol scenario. In Patho GIS platform, there are 5 Patho CERT technologies applicable to emergency situation management, and these technologies collect data in real time and transfer them over to be mapped. These 5 technologies include Patho SET, which generates satellite image analysis results, Patho Drone, which use drone images and data, Patho Invest, which is a simulation of water contamination development using nodes, Patho Cam, which measures water turbidity and temperature, Patho Sense, which identifies the concentration of pathogen, and lastly, Patho Tweet, which is citizens' report on social media. Using these data appropriately and visualizing them on map, Patho GIS platform is able to help those who are in charge to make right decisions. Point data such as Patho Sense, Patho Tweet are graphed so that one can see the general tendency of the data collected over time. Let's take a look at turbidity and temperature. As you can see on the graph, water contamination situation can be aggravating or improving, and depending on the situation, policymakers can decide whether they are in the preparedness phase, response phase, or recovery paths. One can find out how many tweets have been analyzed and accumulated by the Patho Tweet technology, and upon clicking on one of these points, one can view additional data collected by Patho Tweet. If you click on the checkbox to activate the PathoSet, algae estimation results in the form of raster layer are overlaid on map. By using the time series slider, one can monitor the change of water quality over time. In case the situation aggravates and the various sensor values exceed the threshold, warning pop-up is displayed and the user can find out which data are alarming and needs attention. Around the location where many warning data are shown, user can draw a polygon to estimate the area of the danger zone and prevent further development. Let's take a look at Seoul's pilot use case scenario. Since 2014, African swine fever positive cases have been reported, and the reports of these cases have been increasing constantly. ASF positive cases have been reported near Soyang River, which serves as the water source of Seoul metropolitan area. According to Korean legislation, the burial of ASF dead bodies near the river is permitted. However, during the monsoon season in the summer, heavy rainfall causes leakage of wastewater from ASF dead bodies. Using the satellite imagery, the PathoSet technology identifies the boundary of the water surface where damage by the flood is expected. Using the time series visualization, one can see that the water contamination is worse near the location of ASF positive cases. Wastewater from ASF dead bodies further contaminate the water source of Seoul. It becomes necessary that the government takes control of the soaring ASF cases. Using the spatial analysis function, one can view the ASF case analysis results. One can determine the distance of the given point from the SLL, CLL, primary fence, secondary fence. Using these data, policymakers can decide where to further install fences to prevent the spread of African swine fever southward. Using the turbidity sensor, we can view the development of water contamination in Seoul's tap water. As the turbidity increases in tap water, one can also see that the Twitter reports of health problem increases in Seoul metropolitan area. By clicking on one of the Twitter reports on map, we can see that many patients in Seoul are suffering from food poisoning due to water contamination.